Okay, Wildcats. Today we're looking at Thursday, November 1st, factoring by grouping, and that's going to be on page 29. You would update, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. Let's see if we can get it unblurry there. All right, factor by grouping on page 29. Factor by grouping steps. Step 1, group terms. Step 2, factor common binomials from each group. Step 3, factor the common binomial. Step 4, factor the greatest common factor or the difference of squares. All right, so if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, which are on 29. Now, what you might do is take a ruler and add a couple lines to each of the problems. That should help you keep your work organized. So if you want to pause the video and do that. All right, so I assumed if you wanted the lines, you pause it. Now let's go on. All right, step 1, group terms. Well, we have the terms grouped here. Step 2, factor common binomial. So it looks like the largest number I can factor from a 12 and 9 is 3. And the largest exponent I can graph, it looks like is x squared. So I'm going to factor out 3x squared. Now that leaves 4x minus 3 left over. Now, the only thing you can factor from the 4 and the negative 3 is a 1, so plus 1. And so you're still left with this 4x minus 3. Now you know that you can factor by grouping if these two terms are the same. Since they are, and since you're multiplying this by 4x minus 3 and the 1 by 4x minus 3, you can actually put the 3x squared and the 1 together. So 3x squared plus 1 times 4x minus 3. Okay, and that is factored by grouping. All right, let's take a look at example 2. All right, so here, step 1, group terms. Step 2, we factor the common binomial. So it looks like here, the largest number we can factor out is 4, and the largest exponent is x squared, so 4x squared. Now that leaves 3x plus 1. And again, the only thing you can factor from 3x to 1 is a plus 1. So you still have 3x plus 1. Now, you know you can factor by grouping if these are the same. They are. So now we have parentheses 4x squared plus 1 times 3x plus 1. All right. Now let's look at example 3 and 4. All right, now example 3. So step 1, group terms, we have them grouped. Step 2, factor the monomial. So here, it looks like the largest number you can factor from 140 and 60 is 20. We can factor an x from both of those, and we can also, nope, that's it. So what you have left is 70y minus 3x. Now, we look at these terms, and it looks like the largest number that we can factor from 168 and 72 is a positive 24. Which will leave 7y minus 3x. So when factor by grouping, if these two terms are the same, then we know we can factor by grouping. They are. So now we have, wait a second, that's not 70. I'm sorry, that's 7. And one of the ways, if you everything you make a mistake, is you just double check the multiplication. So 20x times 7y is 140xy. 20x times negative 3x is negative 60x squared. 24 times 7y is 168y. And 24 times negative 3x is negative 72x. So now we have 20x plus 24 times 7y minus 3x. Right. Now, looks like this problem, we actually can go into step 3 because it says factor out the common binomial. So here, we can actually factor out from 20 and 24. So the largest number you can factor from those is 4. So then that's 4. That leaves 5x plus 6 times 7y minus 3x. All right, now let's take a look at example 4. Right, step 1, group the terms, they're grouped. Step 2, factor the common monomial. So here, it looks like we can factor in a 1x squared from both of those, which leaves, in this case, 1x plus 5. Then it looks like we can factor a negative 4 from these two terms, which leaves 1x plus 5. So we have 1x squared minus 4 times 1x plus 5. Now, we can't factor in step 3 to factor out the binomial, but in step 4 it says factor the greatest common factor a difference of squares. This is a difference of squares, so this factors to be 1x minus 2 times 1x plus 2 times 1x plus 5. All right, finish up those examples. Now let's look at example 5. All right, group terms, we have them grouped. Step 2, factor common binomials. So it looks like here we can factor out a 3x squared, which leaves 1x minus 7. And here we can factor out a negative 1, which leaves 1x minus 7. So that's 3x squared minus 1 times 1x minus 7. All right, so let's look at example 6. Okay, so here, step 1, group terms, they look like they're grouped. Step 2, factor common binomials. So here we can factor out, it looks like a 4x squared, which leaves 2x minus 1. And it looks like here we can factor out a negative 25, which leaves 2x minus 1. So then we have 4x squared minus 25 times 2x minus 1. Now in this case, there's no step 3 because we can't factor out a common binomial, but step 4, we can actually factor the difference of squares. So 4x squared minus 25 factors to be 2x minus 5 times 2x plus 5 times 2x minus 1. All right, now let's take a look at example 7. All right, so step 1, group the terms. It looks like they're grouped, but actually this one is unique in that there's a 3 in front of all of them. So let's go ahead and factor out a 3 from all of it. So that's 3, 1x cubed plus 1x squared minus 1x minus 1. Now it looks like we can factor out an x squared from here, which leaves 1x plus 1. And we can factor out a negative 1 from here, so negative 1, 1x plus 1. So you're left with 3, parentheses, x squared minus 1 times 1x plus 1. We already factored out the common binomial, but we can also factor difference of squares. X squared minus 1 factors to be x minus 1, x plus 1, and then times 1x plus 1. And if you want to put the 1s in front. All right, let's take a look at example 8. All right, so it looks like we can factor out an x squared from the first two terms, which leaves 4x minus 1. And it looks like we can factor out an 8, which leaves x minus 1. Now you'll notice in all the previous problems that these have been the same and they're factorable. But when these are not the same, we stop and say it's not factorable by grouping. All right. So with that, finish up your examples, and if you understood them, start working on the assignment. If you had some trouble, know that I'm going to be going over those examples again in the teacher-led station. So with that, have a wonderful Wildcat